Okay, so like I mentioned, I'm going to talk about how to save time as a developer, especially if you, well, a Swift developer. That is the minimum requirement. I don't really talk about other platforms, although I tend to write whatever code is needed to fix the problems I face. The name of the talk is improving developer experience. But the key point you have to focus on is if you listen, I am sure you will save at least an hour every day, if not more. And if you are in a position to help your teammates, you actually have ability to scale your impact quite more than you would do if you just focus on being a better engineer as a single person. So my name is Krzysztof Zabłocki, and I spent the last decade consulting with companies and working on making life easier for Swift engineers. I do a lot of open source. This is not all of the projects I have. It just doesn't fit the slides. And my open source runs in over 70,000 applications. So if you have an iPhone, it's unlikely that you do not have an application that uses my code. Whether it's Airbnb, Bumble, Tinder, all of them used my source code. And all of this is free, by the way. Like you can use everything I'm going to talk about. There's like one product that I have that was commercial over the last decade. Everything else is available today for you to leverage. So let's start. So I think that improving developer experience is one of the best investments we can make as engineers, because it's often an afterthought when you design your architecture. You think about the design patterns, you think about how to make your code clean, but you don't actually think about how the day-to-day workflow will work. And so people have the tendency to choose solutions that on paper look great, but in practice require a lot of hassle. Like if you ever use Viper, you know that people write code generator for Viper architecture because there's so much boilerplate you have to do. So thinking about how the actual day-to-day will work is really important. And it's also the thing that will be the biggest return of investment of your time. Because as a single engineer, you have a ceiling. You only have 24 hours in a day. So that no matter how good you will get, if you just focus on your own work, you will run out of ability to make a bigger impact. But if you make 10 engineers better, even slightly, you become a multiplier. And so if there was a 10x engineer, it would be a person that just empowers everyone else in their team. So let's look at what good developer experience allows us to do. So what we want to do is we want to focus on making it easy to achieve the user or business goals depending on the kind of software you work on. You want to create efficient workflows so that you do not waste time doing stuff that doesn't really matter. Like for example, we'll look at a couple of examples, but basically thinking about, okay, I want to build this feature and now I should be able to just focus on doing that work. I don't want to deal with my stack shortcomings. I don't want to run into Xcode builds. I don't want to create unnecessary roadblocks in my way. And I want to be engaged with the work I'm doing, especially important when you do user experience or user interaction work. If you work on animations, for example, any kind of delays that you face will mean that you will experiment less. And if you experiment less, what ends up happening is the end product is worse for it. So your users have, less polished experience. And we want to work smart. We don't want to waste our time. We don't want to kill ourselves just to get the job done. We want to do our work efficiently, and then go home and disconnect. And obviously we want to limit human mistakes because none of us are above it. It doesn't matter if you have 2 years of experience or 20, you will do stupid mistakes. So anything that we can make automatic, anything we can do to avoid relying on humans is going to be a benefit to us. So how can we improve developer experience? So we're going to look at app architecture changes. We're going to look at removing the need for manual steps, for workflow and code automation, for building developer tools, and shortening feedback loops. So the first thing I always ask myself is, how do I even start on this kind of work? Because it's not as simple as I'm just going to automate everything. You have to do some math in your head. So there is a list of questions I ask myself. So the first question I ask is the kind of roadblock, so let's say I'm working on a feature and I run into something that doesn't feel right. So the first question I always ask is this inconvenient just for me? Is this very specific to the kind of feature that I'm building? Or does it affect other teammates? Does it affect the community? Is this common in Swift? Is this a problem at that scale? How often does it happen? Does it only happen once a month? Does it happen once a week? Does it happen every day that we have to face this? And what is the total amount of people in my team that might be doing this kind of work? So even if it's specific to a domain, so like let's say the problem is with the data design of the application. So I know like there are like 5 people working on the data layer in my application, so I'm gonna take that into consideration to evaluate whether it makes sense to automate something there. So let's look at practical example. So the New York Times had pre-processing script, like build phase script that we used to run SwiftGen, SwiftLint, Swift Format, Sorcery, all those tools that probably most of us use. The total on the each build, it added 6 seconds, which doesn't sound like a lot, right? 6 seconds, it's pretty manageable. But I actually measured how many times I built the project per day, and on usual days, it was between 200 and 400 times. And 90% of the time, I didn't really care about those tools because I didn't change code that Sorcery relied on. I didn't really care about linting my code for the development changes that I was doing. And we had 30 developers working on the main application. So even if we take the lower threshold of that calculation, so let's assume just 200 changes per day, we multiply it by the amount of developers and the amount the build phase took. It's 9 hours of development time wasted each day for the company. That is pretty significant, right? It's 1 day. So if you multiply this by 5, you'll see that it means 44 hours per week. So it's like an extra developer. So is it worth investing time? If you spend, let's say you spend 2 days to change this workflow, and you gain 45 hours of development time back, it's like hiring an extra engineer. An engineer salary is pretty big. So I would say like your 2-day investment gives a massive return of investment on it, a lot of money saved. So how did I do it? I created a custom pre-process script that can run both on CI and on a pre-commit hook. And I switched from building with each build, which also meant incremental. So even if your incremental build were fast, as Xcode improves and Swift improves, you would still add the 6 second. So just by changing that workflow, and it took me like a day, I was able to save all that time. And now it's negligible cost. And if you want to read more, I have exact details with the script and everything there that you could use to change your workflow today at my blog. Here's the short link. I'm gonna also post all of the links on Twitter after my talk. So let's look at some common issues that people run into and how we can improve it in our projects. So the first step that I really hate, it's doing manual steps as I'm developing my features. And I've seen this on so many applications. Like say you have a login screen in your application, and I see developers typing their login credentials each time, and it just makes me cringe because you have to do it so often. I really don't like it. I feel like it's a waste of time. And there is a simple way you can do it. So you can use user breakpoints. I don't know if people use normal breakpoints, but user breakpoints mean that they are part of your local machine. They don't actually affect the project. It doesn't change the project file. And it means that the data never leaves your machine. You don't need to generate any git diffs. And it's really easy to disable. So you just create your breakpoint. You set up the actual call. So like you set the text field value, and then you just go about your day. And you can keep that around. You can turn it off and on as you wish. Very simple, very easy. No external tools you need for that. And if you work on a long-running feature, the easiest way to do it is to add a build phase that will give you if defs for your username. So you can simply integrate the script, and then you can write something like if mirroring, then just jump straight to the feature that you're working on. Pretty straightforward as well. Saves you a lot of time. Another issue that is very common, especially since we started using closures, which have been many years now, is retain cycles. And if you have a lot of projects if you have a lot of closures in your project, I guarantee you that you have retain cycles you don't know about. And Apple gives us some tools to work with it, like Memory Graph Debugger and Leaks Instrument. But the problem is that those tools require you to manually, proactively check, which in my experience, humans tend not to do. So, you know when people run instruments in most companies that I consulted with? when the user report that there is like a massive memory usage or the application starts lagging. And the problem with memory leaks and retain cycles is not just memory usage, because oftentimes, especially with the newer architectures based on Combine, what ends up happening is if you leak a controller, it will still fire side effects because it listens to signals from your application. So it also affects your performance. So don't rely on humans if you can automate stuff. So I built this small tool called Lifetime Tracker, and it's based on very simple premise. In most applications, you can define how many instances of controllers can live at the same time. So for example, in most applications, you can only have one login screen, right? So if the application has ever more than one instance of a login screen, it means that the previous login screen has leaked. And it works in both Swift and Objective-C. And what's really nice about this is it surfaces the retain cycles as you are developing features. So once you integrated it, doesn't matter which developer works on the application, if there ever the number of instances crosses the expectation you had, you will get a UI popped in your face. It's not in a console that you can ignore because everyone ignores console logs. It's something that pops up in the application and tells you exactly what's wrong. What's even better is this is accessible, so you can write UI tests that verify that you do not have retain cycle as you go through the application flow. It found so many issues at the New York Times codebase. For example, someone was working on an unrelated feature and they posted on Slack like the ads are leaking, and our ads are very expensive because there were web views. So you can imagine how many resources they were using. So this helped us catch a lot of issues, and the amount of diff you have to analyze between when the changes happened and when you get the pop-up is much smaller than if you used Apple's solution. Because by the time you check using instruments, you probably had months of changes. And with Memory Griff Debugger, it helps you find easy leaks. Like if you have like a strong delegate, for example, that's pretty straightforward. But with closures, that's not the case. Closures are really hard to analyze. So you have to minimize the diffing. And this is how the integration looks like. Like you literally define the name of the object you want to deal with, and you define the count of it. So for most objects, it's like one instance. If you have caching, like for example, for the articles at the New York Times, we had maximum of 3 pre-cached. So we just set the number to 3. If there ever was 4th view controller for the article, it meant we were leaking data. Very straightforward. Another very common issue is data dependencies. And this is an excuse I heard many times from engineers that they say they're blocked to work on a feature because like the backend is not ready. And that is really not what you need to be blocked on. Like it's really rare to be blocked if you define your architecture correctly. So it's a pretty common advice in Swift to structure your data dependency pipeline as a set of protocols. And you can define it like this. So you can define it that you have something that provides the data, you have some kind of decoding, so whether it's a decodable implementation or something more complex. Then you turn that into proper models you might store in database, and then you just use that as a consumer, as a view model or view controller, whatever your architecture is. But with this kind of architecture, it makes it really easy to write tests because you can replace part of the flow, like you can cut off the part of it, so you can just go from the converted to fake models, and then you can test the consumers. So that's one part. It's also very easy to use that pattern to do bug reports. So if you have data for a specific bug, you can just skip the previous part of the pipeline and just jump straight to it. So that works. That's pretty decent. But it's not ideal because, as we all know, the source of most problems is mutability. It's not static data that usually breaks. It's where you have to change stuff and see how the application reacts to the changes live with the previous state being maintained. So what we really want to do is we want to easily load external data to our applications. And in simulator, we would prefer that data to be a local file we have on our Mac so that we can open like Visual Studio Code and edit it live and see the application reflected. But if you're running on device, you need something like S3 or Dropbox that you can put the file on and edit there. That's the easiest way to do it. And what really matters is the real-time updates, right? That is very crucial. So as I was working on one of the client's apps, I built this thing called File Watchers. And it's a very simple generic implementation. I think it has like 2 files and works in Swift and Objective-C as usual. And there is local and remote file observer. And that means that for the local, you can point it to anything in your, like if you're running a simulator, just point it to your desktop, for example. And if you care about remote, it supports last modified and ETAG headers. So whether you put it on Dropbox, you put it on remote server of any kind, S3, you can edit live. I normally put it on Dropbox and I just open Visual Code and then it just updates immediately. And the way this works is you integrate it at the first layer. So when you had your normal data provider that would hit your REST API, you just replace that part with the file watcher, which is like a single line integration. And if you do that, you can do something like this. So this is actually how the New York Times application looked like when I joined. We started rewriting it. So on the right, you actually see what you see nowadays as a newsreader. And on the left, we had like a massive JSON that we were getting from the server. And this was using file watcher. So as you see, when I save the local file, it will immediately reflect in the application itself. And this is how we developed the whole API before the servers were even ready for us. So this is a massive time save for us and for other projects. I tend to use live file watchers for a lot of development, because if you can get real-time updates, you will save a massive amount of time. Simple as that. And if you cannot reproduce bugs because your data changes often, every app has to deal with, like if you think about this, right? So if you have an application that has a frequent data feed, like the newsreader is one example, news changes very often, so, but there's a lot of other applications, like Twitter, for example, anything that has frequently changed data. If your data changes very often, you will get bug reports from your users that are related to the specific configuration of data you had at a specific moment of time. Now that's a problem, because we do not work on bugs the day they are reported most of the time, right? The bugs go through triage, the bugs are scheduled, and then like a month later, someone asks you to fix a bug. That month later, it's really hard to reproduce the kind of data that the user saw. So it's really hard to reproduce the bugs that they got. And it's not trivial. Even if you have multiple environments, you would have to have an environment for each developer to really be able to do it, because usually you are competing with other developer needs. So if I have staging and test staging, but I have 30 developers, it's very likely that multiple developers will want to change the same data to test different bugs. So that's not very convenient, because you run into synchronization issues. But there is a simple solution for that. Every single application that I have ever seen deals with raw data at one point or another. So there's always a place where you're processing bytes. And usually you can identify the kind of data you get. So whether this is coming from like the home feed, whether this is like mentions feed in Twitter, there's usually some unique identifier. So what if the only thing you needed is the raw data, the identifier, and you had a function that you pipe it through and you get data back? And so in your, regardless of the architecture of your application, you have this pure function that you call, and you use, rather than use the data that you got from the server, you use the data it returns. Very simple premise, right? Everyone can do it. So now your application works in 2 modes. The default is recording mode, where the data that it gets as an input, so the data downloaded from the server, gets also put into a cache folder on your device. Or it works in reproduction mode, where the data that it gets in gets ignored, and the data from the cache folder gets returned. So in the first scenario, the input is the output, so the data is whatever the server gives you. In the second example, it's a different data. But everything else in your application, it doesn't know, it doesn't care. What this allows you to do is to pretty much test 90% of your application, except that like literally that only one line is not tested, so you can reproduce a lot of bugs. And I have a blog post about how this works in detail on my blog, but I'll show you how it looks like. So this is how it looks like in New York Times. So when you have a bug report on the left, you can see that there's like a hash identifier on the bottom right. And then on the right side of the application, this is a beta settings from the application. And you can just load Jira snapshot and you can pass in that identifier. If you pass in that identifier, what the application does, it will fetch the data from S3 bucket, it will put it in caches folder and change your application to reproduction mode. So now, even if you are working on a bug a month later, you will get exactly the same data that your user had. So reproducing bugs is now a matter of 15 seconds instead of 3 or 4 hours. And it also means that you do not compete with other developers for the same kind of configurations. Very convenient. If you need more power, you can build something like time travel. So if you have an architecture like TCA, that's pretty straightforward. But even if you don't have TCA-like architecture, this is actually using Objective-C runtime. I mentioned this yesterday, that this actually records the runtime invocation of Objective-C and then sends that information to the server. And then when I restart the application, I can replay all of that. So this is very complicated and technically, but you can build something like that if your architecture supports Redux-like pattern. So today, a lot of applications do that. It's extremely powerful because you can reproduce crashes, like a step before the actual crash happens with the debugger connected, and then you do the last step and you get exact detail. So the bug reproduction goes down quite critically, very convenient. Another issue that I faced a lot of the times because I do TDD is Xcode doesn't, like Apple doesn't really do tests very well. Let's say that. This is the kind of debug information you get if your test fails, if you do equality on complex objects. Can anyone tell me what's wrong? Yeah, that's the problem. So I built this small framework called Diffs. It's like a single file, mirror-based API. If you include it in your project, this is the kind of information you get instead. So it tells you exactly which key at which place in your structure differs and how it differs. This means that when you get a test failure, you can immediately just go and fix it. Much more straightforward. Having to analyze this kind of code it's ridiculous. Don't do that. Just include something like this. Very simple. Another issue that people run into is a lot of boilerplate, especially in Swift as a very strongly typed language. Every single project I consulted on had some kind of boilerplate, could be replaced or automated. Even if it's not fully automated, maybe build in like the generator kind of implementation where you start with the same pattern and then you manually maintain it. So I built this tool called Sorcery. And it works like a preprocessor. So Sorcery basically as an input gets Swift code, as an output can generate more Swift code or anything else. There are people that generate Dart from Swift. There are people that generate JavaScript bindings. A lot of use cases, extremely powerful. And it's used in over 40,000 applications like Airbnb, Bumble. It also adds annotation support to Swift language, which means you can build a very customizable templates that have fine-grained control. And if you can describe an algorithm to a fellow, to another engineer, you can describe it to Sorcery, and that means that you no longer have to describe it again. You just implement it once and then apply it across your whole code base. And Sorcery can be used for a lot of things. You can use it to introspect your projects. So a lot of the times when I get hired to consult on applications, people ask me to review their whole code bases. And the first thing I do is I want to see the structure of like how many protocols they have, how many classes, how many structs, because this is like a good information to have. So I can just write a simple query using Sorcery and I can learn that the project has 600 types, for example, like here. But it enables much more powerful things. On the left side of it's another project that I have, like everything I'm talking about is open source. And it's on my GitHub. So the project I have on the right, the code I have on the right, is all the code that you as an engineer would have to write. It's basically the description of the data you want to be changing. So every single application that I've seen has some kind of debug settings. So you have beta settings or whatever you call it. You have those kind of information you want to control as you develop your application, so you can test different workflows. You can tweak the behavior of the application. So this is the code you would have to write on the left. Everything on the right is generated. All of the UI, all of that bindings is done by Sorcery. You don't have to write any of it. Which means that if you want to add an extra variable to your beta settings, the only thing you do is on the left, you add a variable. Literally the only thing you have to do. And it supports custom types. So if you want to add a completely custom type, the only thing you have to do is you add a pure function that returns SwiftUI editor for that type. And Sorcery will still generate all the bindings for it. Extremely powerful. Another example is beta settings. So at the New York Times codebase, we use a lot of A/B testing. And on the left is literally the definition of how the tests look like. On the right is all of the UI generation that happens by Sorcery that lets you override the tests for QA and for developers. Very similar pattern. Another pattern is we generate for the AR kit bindings that I wrote a platform for the journalists to basically write AR experiences like games. So it predates TCA, but it's using similar pattern of like a reducer kind of thing. So what I do here is I define the kind of actions that the JavaScript can do. And then from that, Sorcery generates all of the code to translate from JavaScript to native Swift types. So at the top are definitions of commands that the application can perform. And then what happens is we generate a protocol, protocol implementation that converts that into fully typed enums. So you as an engineer, the only thing you do is you get an extra case you need to handle, and at the point where you need to handle it, it's already fully typed. So it's not using JSON, you don't need to deal with any of that. It also supports automatic error handling, so if the JavaScript uses wrong name for a variable or uses wrong type for a variable, it will automatically report the error to them, and you as an engineer don't have to deal with that. But it's a dependency, right? It's a very low dependency because Sorcery works like a preprocessor. It doesn't force you into any kind of architecture. It doesn't force you into any kind of pattern. It's all your control. Some people would still don't want to use it because it's a dependency. So I built this small application called Sorcery Pro, which has Xcode live templates. And that means that in your Xcode, rather than having, oh my God. Oh my God, 1 second. Yeah. So basically, I have built this thing that has its own editor that lets you write custom templates. And then from that custom template, what you can do is you go into your Xcode. This one, yeah. So, Jesus. You go into, sorry, technical difficulties. So this is Xcode, right? In your Xcode, you have an extension, and you can write templates that you defined. So you know how Apple added codable implementation for enums with associated types in the newest Swift? Sorcery had it for 6 years. So even if you don't use the new Swift, you could simply use this, and you can generate all of that code. So here's an example how to generate mocks. You can generate pretty much anything. And every project has the patterns where you have a lot of repetitions. You can automate that quite easily. And it also has like an editor that basically gives you IntelliSense, errors, makes it very easy. It basically guides you by the hand. If you never wrote Sorcery template, you can do it without reading any documentation, which is pretty convenient. It's available on Mac App Store, and it's also available as a separate distribution. So now that we know how Sorcery works, another issue that you face often is testing, right? When you do testing, when you have protocols in your application, you have to provide mocks. Every mock should pretty much look the same. Like the stuff you want to validate in your applications is usually whether a function was called, what were the arguments that it was called in. You want to trigger the side effect. So like if your protocol has a completion, you want to be able to call that completion. So we can describe the algorithm for what a mock should do quite straightforward, right? We can define the common ground. And if you can do that, then you can use Sorcery to do it. So Sorcery comes in with auto-mockable template that you can use for free, but there are also other products built on top of Sorcery, like Swifty Mocky, that gives you very fancy API that you can use for testing. If you ever use OC Mockito or one of the older tools, this is basically it. So you have this like verify that something was called. It's very convenient, very powerful. And also, like I showed before, like you can just use Sorcery Pro to get the mocks. If you don't want to fully automate it, you just want to generate a mock, and then don't tell other engineers in your company that you're using Sorcery, and basically, make yourself look good. Then you can just use Sorcery Pro for that. And the last issue I want to talk about is iteration cycle. This is last, but is by far probably most influential, that if you apply today, you will save hours every week at the minimum. So when we switched from Objective-C to Swift, our build times exploded, right? All of us face that Swift compilation is pretty expensive. And so waiting for compile times is not fun. You're watching the Xcode spinner, you get distracted, you check your Twitter, your Facebook, pretty common, all of us do it. There isn't anything wrong with it, except you're wasting your time. So how many people are remote? Can I see the hands? Yeah, quite a few people. So when you're remote, you don't get evaluated by the amount of time you spend, but by the kind of output you generate. So if I told you that if you apply some of the stuff that I'm going to show you, you'll be able to work 1 hour less, that's pretty valuable, right? Pretty convenient to work less and do the same kind of work. So let's look at how we can do that. Let's first run some math, so you have the exact details. So the time per iteration between building the project, restarting the simulator, getting into the same screen and configuration you were on, let's assume it's like 25 seconds, might be less, doesn't matter. As I mentioned, I measured how many iterations I do per day, and it was minimum of 200 to 300, so let's use the 200, and then we multiply that. So you see the amount of time you're wasting just waiting for the restart of your cycle. So if you do 100 iterations, it's already, 0.7 of an hour. I don't know what is, like 40 minutes. If you do 300, it's 2 hours wasted just waiting for Xcode and waiting for the restarts. Quite significant. So the first thing you can do is split your project into many different modules. A lot of us are doing that. This has a lot of benefits outside of just the iteration cycle because it improves modular architecture design. It forces us to think about the boundaries of our modules and minimizing the public API because all the public API should be tested. We all do tests, right? And the tests will be smaller because each module has its own. It doesn't have to run everything. And you could use playgrounds or small projects, although I don't recommend that. And it used to be that the dilib loading was a problem. That's not really longer a big concern for most applications because of the improvements that Apple did. So back in 2014, I made this project called KZ Playground, which is basically like an Objective-C and Swift playground. So this was back when Swift was announced. Apple released their playgrounds, and they were absolutely terrible. They would constantly crash. And it was pretty simple, and it worked with this tool called Dicey and then injection for Xcode. This is how it looked like. So this was how it looked like. It ran as an iPad application, and you get on the left, you get timeline view, and on the right, you see the workspace that you develop in. And as you saved files, you would get the results reflected immediately. Back then, Swift playgrounds were like at least 10 times slower. They also crashed, and they also didn't support full simulator environment, which meant you couldn't do stuff like perspective transforms, a lot of limitations. So I used this for many years, but I realized that it has to run in an iPad application. You cannot use it for Mac. There was a lot of limitations, even though it was pretty fun. So I come up with something simpler. What if I told you that the only thing you had to do in your project is change maybe 2 lines of code to be able to hot reload Swift? 2 lines of code. And you can develop UIKit applications, AppKit applications. So this is actually an example from a real application. I changed a single line from just building the view, like creating the view controller, to creating a view controller through a host, which is a pattern that I have in a framework that I built. And this is the output of it. 1 line of code changed, and now you can develop UIKit application in real time without restarting your simulator, without refetching your data, without previews that require fake data, with full debugger support. Every code you change, if you add a breakpoint, you can check what's going on. You don't have to wait for anything. Live coding in Swift. And this is a demo from Dario Roa on Twitter. So I open sourced this on Monday, and there's like 70,000 views already on this project. Another example of this, if you have Swift UI application. So that was an example that works with UIKit and AppKit. If you have Swift UI, you need 2 line changes. One is adding a variable, and the other is at the end of your Swift UI body, just calling enable injection. If you do that, this is what you get. So this is a pretty complex application for movies. And you can edit everything, and everything gets reflected immediately. It's not previews, it's real application with real data fetched from the servers. This means that the bigger the application, the bigger the benefit of using the tooling like this. And the integration, the nice thing about those integration points, you don't need to change those lines, because those lines in release builds turn into no-ops. So the variable that you add is an empty variable, so it will cost you like 4 kilobytes, whatever the minimum is for the pointer. And the enable injection in production just returns self, so it doesn't change anything. This only applies to debug builds. So when you're developing, you get all of the workflow improvements for free. You can commit this to your application. You can release it on App Store. Everything will be fine. So there is no cost of you cleaning it up. And this is... So this is a demo from Ibrahima Cis on Twitter. So people are using this. And this is especially useful if you have big projects and you cannot just modularize everything. So you can get it for free. It's called Inject on my GitHub. And then you run an application called Injection for Xcode, which John wrote. And I worked with John to optimize and extend the features of this tool. So even if you tried it years ago, it has improved quite significantly. And it allows you to work on both Swift and Objective-C code bases, even mixed code bases. There's no runtime involved. The way this works is using LLVM interop. So you can inject Swift types. You don't need to limit yourself to just old projects. It has full Swift support, including enums, all this stuff. You can even, if you use TCA, I have a fork of TCA that we use at the browser company. And you can inject reducers in live applications. You can change the business logic. And it can be integrated as SPM package as well, very straightforward. So to summarize, creating a good developer experience, I think I convince you that it's worth your investment. It will give you a massive return of your time. And if you're in position that you have like a big team, if you take your time to do this, it will multiply per developers you have, because you will optimize each one workflow. And if there was ever like a 10x developer, it would not be the brilliant asshole that can code, a massive amount of code in short time. It's the person that's empathetic and thinks about how I can make life easier for the other engineers in my teams. So if you want to be the 10x engineer and be considered like that, but also be a nice person, because this makes you a better person, try to focus on this kind of workflows. And yeah, ask yourself the questions I posted in the beginning. Is the problem or inconvenience you're facing, is this only affecting you? Is this something that's affecting your whole team? Maybe it's something affecting the whole community. Maybe you can build an open source project and share it with the world so all of us can develop. Those projects are not very complicated. It's more about having an idea, seeing the problems differently. Consider getting Sorcery Pro if you want to automate some of your workflows. And definitely give Inject a try, because I guarantee that it will save you time. And if you run into any issues, I'm always available on Twitter. So happy to answer any questions.